Hello, everyone, and welcome to this week's edition of Cloud Native Live. This one about the Kubernetes 1.34 release, with a specific webinar that we'll use to highlight everything new with this latest Kubernetes release. Be sure to leave your questions for our speakers and also to say hello in the chat so that we know that you're watching. This is a CNCF live event, and as such, it's subject to the code of conduct of the CNCF, so be mindful of that and do not say anything on the chats or in the questions that can be constituted as a violation of that code. This is a cloud native event, and in these events we dive into the code behind cloud native. I'm Frederico Munhoz. I am a CNCF ambassador, a global technology practice cloud architect at the SAS Institute, and coincidentally enough, I'm also the 1.34 emeritus advisor for the 1.34 Kubernetes release. I will be your host today, and I'm excited to have with us members of the Kubernetes 1.34 release team that will, as I mentioned, present the highlights along with everything that's new in this latest release of Kubernetes. With that, I will quickly share my screen and start the presentation, and also allow for for each individual release team member that has joined us to the opportunity to have to make a quick presentation. And I'll start with the 1.34 release lead, Vyom.
Hey everyone, I am Vyom and I led the 1.34 release cycle. I work in the security team at Canonical. Apart from that, I've been involved in the release team since v1.27. So it's like, 7-8 releases so far. And every release has been pretty enjoyable. And I also serve on the Kubernetes Security Response Committee. So quite involved in things around Kubernetes and open source. And glad to be discussing v1.34 today.
Excellent. Thank you very much, Vyom. Jenny?
Yep. Hi, I'm Jenny. I was the enhancements lead in 1.34. I've been on the release team since 1.32, mostly all on the enhancement side. In my day job, I'm a software engineer at solo.io working on API gateways.
Excellent. Thank you very much, Jenny. Agustina?
Hi, everyone. My name is Agustina. I served as communications lead for the 1.34 release. I've been part of the release team since 1.33, and I have the joy of continuing to work for them in 1.35. In my day job, I am a staff software engineer for a global company called Veritran. Veritran, in case you don't know, specializes in banking solutions through its low-code platform. I work on the infrastructure platform, developing and implementing cloud services. I am very passionate about open source. I use multiple open source projects, and I take every opportunity to give back. So I'm very happy to be here with you today to share what's in this release.
Excellent. Thank you very much, Agustina, Jenny, Vyom. And that passion for open source leads me directly into something very important that I would want to start by highlighting, which is we couldn't have made the Kubernetes 1.34 release or any other release for that matter without that same measure of passion, involvement, and work that we have in the Kubernetes release team. The Kubernetes release team is made of volunteers, both leads and shadows, that work relentlessly to bring the Kubernetes release to its current state. This was the Kubernetes 1.34, and organized by different teams: release lead and shadows, branch management, enhancement, release signal, docs, comms. We had an amazing team that deserves a very special word and recognition at this time. Speaking of work and recognition as well, I think this is the right time to give the floor to Vyom so that he can actually talk a bit about the Kubernetes 1.34 name, logo, and everything that it implies. Vyom.
Thank you for that, Fred. V1.34 is a very special release for me of course, because I'm the release lead, and this kind of marks my end in the Kubernetes release cycle. So when I was coming up with the theme and logo, the thing that I was trying to put on paper was actually what I've experienced throughout my journey. So I've been on like 7-8 cycles on the release team. Each and every cycle I've had different experiences, different learning experiences, met new people, and just saw how this team evolved at the same time how Kubernetes evolved as a project where it is today. So when I was thinking and coming up with the theme, there were certain elements that I wanted to incorporate in the logo, etc. I'll get to that later. But what it essentially boiled down for me was that it's actually a lot of perseverance that people show when they are contributing upstream, because sometimes you might not get reviews in the time frame that you want, but still people keep going, they keep pushing. So rightly so, I named the release of Wind and Will, because wind is the external factors that we all experience while contributing to open source. And sometimes it's the state of the tooling, the state of the documentation, or the processes in general. They're not the most ideal, but at the same time, wind is required. The analogy of a vessel in the medieval times, which had large sails, the wind is required to push that vessel forward. But at the same times, those winds may sometimes kind of destabilize the ship, and sometimes the winds just die down. But eventually what it comes down to is the will of contributors, or the will of the people who actually steer or man this ship or board this ship to actually get this to the destination and get this through the ocean. So the release is called Of Wind and Will. There's a wordplay with OVAL, which I need not explain. But this release is dedicated to those people. It's dedicated to the winds that have shaped us and the will of the contributors that keep us going. So that's kind of my small tribute to all the contributors and all the people who put in the effort to get Kubernetes to the stage where it's at today.
Excellent. Thank you very much, Vyom. And Jenny, maybe we can have a quick highlight on the enhancements for this release.
Yeah, so just some background. You'll probably hear us use the terms enhancements and KEPs interchangeably. What is a KEP? It stands for Kubernetes Enhancement Proposal, and it refers to a proposed Kubernetes feature or like an architectural change that we track usually across multiple release cycles. Usually starts out with like some discussions, maybe initial design document, then it gets formalized into a GitHub issue and a KEP document that includes like stuff like motivation, proposed changes, how you plan to test it, graduation criteria from stage to stage, and production readiness questionnaires, and so on. So the KEP issue and these documents are long-lived, and they're updated as the enhancement progresses through the various stages, like alpha, beta, stable. And these are so the release team uses these to track which enhancements are going into each release, including like what stage they're in and whether they've met all the requirements to be tracked in the given release. So with that, in 134, we tracked 58 enhancements, of which 13 were in the alpha stage, 22 were graduating to beta, and 23 graduating to stable. Additionally, along with those, there were a couple of deprecations or removals, which we'll go into a bit later. And just to add, like a KEP can fall into multiple buckets. So it could be graduating, for example, to stable and also be deprecating something at the same time. If you want to see a full list of the enhancements we tracked in 134, here's a link to the GitHub tracking board.
Excellent. Thank you very much, Jenny. And with that, we will actually go through a selection of the enhancements that constitute the release highlights that we have gathered. They are organized by the SIG, Special Interest Group, that owns it. As Jenny briefly mentioned, the Kubernetes project is organized primarily into special interest groups, or SIGs, and each SIG is comprised of members from different companies and organizations, but that's focused on a specific topic and have a specific scope. like networking or documentation, and they are typically the owners of the code that applies to that scope. And one or more SIG owns a specific enhancement. Most of them have one SIG that is the owner. Some enhancements are more cross-cutting and have more than one SIG directly participating. And the first release highlights that we will focus on are the ones on SIG API machinery. SIG API machinery is the SIG that covers all aspects of the API server, API registration, discovery, CRUD semantics, etc. Also the things around the open API, custom resource definition. So all things API related end up under the SIG API machinery scope.
All right, so yeah, the first KEP that we want to highlight is KEP 4988 snapshotable API server cache. This graduated to beta in 134. So historically, API server list requests have been a source of high memory usage and heavy load on etcd. There have been improvements made over the last several cycles to make it so that almost all the read requests can now be served from the cache. But before I get into 4988, there's a couple of other KEPs listed here that work in conjunction with it that both graduated to stable in this release. So below KEP 2340, consistent reads from cache. This allows most of the read requests to be served from the watch cache instead of etcd, while still providing consistency and freshness guarantees. And KEP 5116, streaming list responses. So when you make a list request to the API server, it encodes the response in the requested format. And historically, the whole response would be encoded at once, which would cause memory spikes in the API server. So KEP 5116 implements streaming encoding of the responses so that, for a large list response, each item is encoded and returned to the client separately to avoid the large memory spikes. So coming back to KEP 4988, so this one enables the watch cache to efficiently generate and store snapshots so that we can do historical list requests, for example, used in pagination. So now it'll just query the cache instead of needing to go to etcd. So with all three of these KEPs together, read and list operations are now much more efficient and with a lower memory footprint.
Excellent. We will move to the next set of highlights. This one owned by SIG Network. As the name obviously implies, SIG Network is responsible for the components, interfaces, and APIs which expose network capabilities of Kubernetes, and also owns the reference implementations of those APIs, covers kubectl, etc. So a couple of highlights there.
I'll take this one. So this one is about the DNS config searches list within a pod spec. In the past, Kubernetes validated strings in this list according to RFC 1123, which defines some restrictions for host names. And this meant that creating pods with search strings non-compliant with this RFC resulted in a creation error. You couldn't even run the pod. However, in practice, some legacy workloads sometimes include underscores in DNS names, and DNS servers will generally allow this. And secondly, some users may require a DNS entry to resolve to an external domain first before an internal Kubernetes domain name, which could be achieved by setting a single dot as the first entry in the searches list. So to solve both use cases, this KEP 4427 relaxes validations around DNS search strings by allowing both underscores and single dot values. It was introduced as alpha in Kubernetes 1.32 and has graduated to stable in Kubernetes 1.34.
Thank you very much. And we move to SIG apps. Now, SIG apps covers the deployment and operation of applications in Kubernetes, and also focus on the developer and DevOps experience of deploying and running and maintaining applications in Kubernetes. And We have also highlights here. Let me So, anyone wants to take the SIG apps?
Yes, I'll take that one. Delayed
Perfect.
creation of jobs replacement pod. So, as you know, right now, what happens in Kubernetes is that if you have a job that's failed, it would start creating replacement pod as soon as the pods that failed are in the terminating state. So those pods haven't fully terminated, but they are in a transitional phase where they are being terminated. Now, this can cause problems for a variety of workloads. For example, if you have some application that is only licensed per pods, you might have two active running pods with that application at the same time, which might pose problems. Or if you have some applications which index on the number of pods running at a point in time, then also it can cause problems for a workload. Of course, there is the additional resource usage, which would be the pod hasn't terminated, but you are creating a new pod. So this cap actually brings a new field called pod replacement policy. So you can either set this to terminating or failed, which is the current behavior. So the pod replacement would start either when the previous pod is in the terminating phase or in the failed phase, or there's a new value that is in pod replacement policy now, which is failed, which means that the new pods would only be created after the previous set of pods have failed and the resources have been deallocated. Another good example is for quota controllers. Quota controllers actually count the number of pods that are there to do what they do. And if there are more than the required amount of pods that are there because of pod replacement policy being set to terminating or failed, which was non-configurable before, that might cause some problems there. So with this cap, this brings you the flexibility of defining what you want to do with your pod replacement policy. This cap this was alpha in v1.28, became beta in 1.29, and then through multiple cycles of testing and getting user feedback, it has finally graduated to stable in this release. So pretty amazing feature and requested by a lot of folks.
Thank you very much, Vyom. We will now move into the highlights for SIG auth. SIG auth is responsible for the design, implementation, and maintenance of features in Kubernetes that control and protect access to the API and other core components. So the main focus is authorization, authentication, and cluster security policy. And we have some highlights here.
Yep, so I'm going to cover a couple different features for SIG auth. The first one, service account tokens for image credential providers, KEP 4412. This one graduated to beta in 1.34. So for background, kubelet credential providers are used to authenticate to registries when you try to pull private container images. And these historically used long-lived image pull secrets that were stored on the node and didn't get rotated. They could also be accessed by other pods on the node, so the security wasn't great. With KEP 4412, the kubelet can now request ephemeral service account tokens to authenticate to the image registries. And this greatly improves security because the tokens are short-lived and automatically rotated, and they're based on the workload identity, meaning that each pod can only pull images that it's allowed to access.
Excellent, thank you.
Yeah, the next SIG auth one, API for external signing of service account tokens. This also graduated to beta in 1.34. For background, again, the Kube API server uses service account keys for JOT signing and authentication. These service account keys were historically stored on disk and loaded at Kube API server startup, meaning that if you wanted to rotate them, you would need to restart the Kube API server. And it also presented a possible security risk because the signing keys were stored on disk where they could be potentially accessed or copied. With KEP 740, we can now integrate with external key management solutions for service account token signing via a gRPC call. This is done through a new external JOT signer API. With this feature, we get improved security and ease of use because we don't need to handle static keys stored on disk or deal with rotating them because the signing is done externally. And this feature is enabled by default in 1.34.
Thank you very much. With that, we have the highlights for SIG auth, and now we move on to highlights from SIG storage. And SIG storage is responsible for ensuring that all different kinds of storages, ephemeral, persistent, local, remote, block or not, are provisioned, created, attached, mount, etc. So everything that's around storage, including the driver approach, scheduling, etc., falls within the scope of SIG storage. And we do have highlight here.
Yeah. So in the past, Kubernetes did not support update of volume attributes other than the capacity after provisioning. That means that you could change in a persistent volume claim after creation of the volume values like the size, and that would cascade in expansion operations in the underlying storage. But that was the only field that you could change. This in 1.29 changed because it introduced a generic Kubernetes native API for modifying volume parameters called volume attributes class. And this API that has graduated to stable in Kubernetes 1.34 allows workload developers to vertically scale volumes online. This is, of course, if supported by the provider, so always check that. Some examples of volume attributes are I/O quality of service parameters like IOPS or throughput. And you can think of this as profiles for your persistent volume claims. They can start with a profile, but later change to another one, and the attributes will shift dynamically. Like all new volume features in Kubernetes, this API is implemented through the Container Storage Interface, or CSI, which means that your provisioner-specific CSI driver must support the Modify Volume API, which is the CSI part of this feature. We have a blog post on this, and there you can see that volume drivers like EBS and GCE already support this. So if you're using those storage classes, you can upgrade and use this feature. If not, check with your storage provider.
Thank you very much, and we'll move right along SIG CLI, which covers a well-known kubectl or kubectl or several different ways of saying the same thing, and related tools with a focus on POSIX compliance and maintaining a sane and useful CLI framework and dependencies. Highlights here for, and this goes directly into one of the comments that we have in our chat, which is around Camel.
Yes, KML, or KML, as with kubectl. There's actually a game at, I think, KubeCon NA24, in which it was like, guess how many different pronunciations are there for kubectl. So yeah, KML, the big thing that a lot of people have been discussing and commenting on Reddit about. So what KML basically is, that KML is a subset of YAML, which is kind of similar to JSON in some sense, but it comes with its own feature set. So I want to make it very clear going with KML that KML is valid YAML. KML would work with any YAML parser or any tool that accepts YAML. YAML is not going anywhere. KML is just a subset of the grammar that is defined in the YAML specification. Why KML was built? Because the YAML had some limitations. YAML is a very wide specification, and the Kubernetes community wants to pick out the specific grammar that is the most useful out of the specification and use that to kind of display things on command line. So a lot of good features in KYAML are there. First of all, it does not depend on white space, so you don't have to manually indent your YAMLs. That is gone. Another good thing is that there's a popular thing called the Norway bug. So the Norway bug, what it means is that in YAML, certain strings mean Boolean values. For example, no, capital N, capital N-O, and so all these things kind of translate to Boolean values, and underscore number underscore, that also translate to an actual number rather than expecting it to be a string values. So there are quirks like these in the YAML definition that if those things are being used as keys, they would be coded so that there is no ambiguity. and it also quotes the values that are being passed in whatever a key or value structure is there. Another great thing for KML is that it allows comments and it actually retains comments, which is a very nice and welcome feature. And it's easy to read. A big problem with YAML is templating. So whenever you are templating YAML, you have to kind of get those white spaces right, or you would face the problems of that YAML being invalid. So with KYAML, that problem is no longer there. So it brings in a lot of great features out of the YAML grammar while still being absolutely valid YAML that any parser can parse. So we have been trying to refine the YAML grammar for it to be the most useful to the users. And a lot of people have said things about this on Reddit. So the maintainers are more than open to have real world use cases and feedback on this feature, because this is an alpha kept, which is alpha in this release cut. So as many requests or suggestions you have, the community is more than happy to accept those and think about them and include them in the newer versions.
Excellent. Thank you very much, Vyom. And with KYAML, KYAML, we move on into the highlights for SIG Node. SIG Node is the SIG responsible for the components that support the interactions between pods and host resources. So it manages the everything that is around the life cycle of pods that are scheduled to a node, and including hardware-specific workloads and settings. We have highlights from SIG Node as well.
Yep. So Linux node swap support kept 2400. This graduated to stable in 134. This feature allows for flexible memory management by letting you turn on swap memory support on a node. This is done by setting the value of the memory swap behavior field in the kubelet configuration. So this field can have one of two values, either no swap or limited swap. So by default, no swap is used, meaning that workloads or pods running on this node can't use swap. But if you set this field to behavior to limited swap, that means workloads can use swap memory, which can help improve the stability of the node. For example, if a pod is encountering a memory spike, swap memory can be allocated to it temporarily to prevent it from running out of memory. So when you turn on the swap behavior, you don't need to configure anything specifically. It's just basically a flag that you turn on. The amount of swap available is determined automatically based on things like how much memory is requested by the pod and how much memory is available on the node.
Excellent. Thank you very much. Now that we're done with the SIG Node highlights, we move into the highlights for SIG scheduling. And SIG scheduling is responsible for the components that govern the pod placement decisions, which includes the Kubernetes schedulers and the scheduling features of pods.
Yep, so this one is me again. So per plugin callback functions for efficient requeuing, kept 4247. This graduated to stable in 134. For some background, the kube scheduler is a control plane component that assigns nodes for pods to run on, and scheduling plugins can define scheduling behaviors for the various stages of scheduling. Sometimes scheduling of a pod fails and it needs to be requeued. So kept 4247 exposes a new queuing hint callback, which allows a scheduling plugin to determine whether a pod should be requeued based on specific events. This makes scheduling more efficient because it can avoid requeuing pods that are not likely to succeed. And at the same time, it can also retry more quickly for things like DRA, where we expect some failures in the beginning and we want to retry without waiting for backoff delay.
Excellent. Thank you very much. And we're now moving to a slightly different, but obviously related aspect of the work that was done in this release, which is on the device management workgroup. A word about the different naming here. We're not talking about a SIG. We're talking about a workgroup, and in the Kubernetes community, a work group are primarily used to address topics of discussion that are cross-cutting in nature and that cross SIG lines. Working groups provide a formal venue for those discussions. They are typically a group that has a clear goal, is time-boxed, and importantly enough, it doesn't itself own any of the code. The participating SIGs are the owners of the code. And we have highlights for the device management workgroup, which is such a work group that deals with things related with device management, like, for example, the dynamic resource allocation.
Yeah, I'll take this one. And if you've been following the latest Kubernetes announcements, you know we've been mentioning the array a lot. The core of the array is now generally available. I'll try to catch you up in the history of the array and what it is. So dynamic resource allocation, or the array, provides a flexible way to categorize, request, use, and even share devices like GPUs or really any custom hardware in your Kubernetes cluster. This feature has seen some ups and downs. The initial implementation was introduced in Kubernetes 1.26, but after finding that resource availability was not transparent and affected the decision-making for cluster autoscaling and other controllers, the decision was to remove it in Kubernetes 1.32 and replace it with a new proposal. So in Kubernetes 1.30, it introduced a new design that enables claiming devices using structure parameters that are opaque to Kubernetes. And the working group took inspiration from dynamic provisioning for storage volumes. So some of the APIs will sound familiar. We have the resource claim, device class, resource claim template, and resource slice are the APIs that are now available, enabled by default, and stable. On the pod side, we have the array extending the spec with a new resource claims field. And the way it works is with the array, device drivers and cluster admins can define device classes that are available for use. Workloads can claim devices from a device class within this device request section. And then the matching happens. Kubernetes allocates matching devices to specific claims and places the corresponding pods on the nodes that have access to those allocated devices. But the core of the array is not the only enhancement in Kubernetes 1.34. We have other the array related enhancements in the next slide.
Yes.
I'll go with these ones. So there are a lot of DRF features that are going beta, alpha in this release. So I won't cover all of them in super detail, but I'll just walk you through what each of these gaps here are basically for. So first talking about GAP 5018, admin access for secure resource monitoring. So right now, if you have a device that is bound to a pod and you want to actually do some admin work, maybe run NVIDIA SMI or do some monitoring of that device, that wasn't really possible in a secure way. So this GAP basically allows admins to access that device while it is still being utilized by that workload to kind of perform diagnostic stuff or monitor things on that device. So this allows to do that in a secure way using RBAC and already existing control mechanisms in Kubernetes. The other one is GAP 4816, which is about alternatives of resource claims being utilized. So let's say you have a workload which works on a particular kind of GPU, but that workload can also work with two smaller GPUs combined together. So kind of having this option to select from if a particular kind of device is not already available, that is what prioritized alternatives allow you to. So you can do basically a one-off from the available devices in that cluster and still get your workload scheduled instead of it not getting scheduled. The other cap is cap 3695, which is kubelet reports allocated DRA resources. So this basically allows pod resources API to kind of expose the devices that are being used by any particular pods. So any node controlling agents or any node monitoring agents can kind of see that information and do any kind of logic that they want to basically extend the pod resources API, consume the logic from there, the information from there, and extend it to their business use case. The other one is the alpha KEP, which is KEP 4680 resource health status. So right now you don't see the actual status or the health status of devices that are bound to pods. In Kubernetes, this alpha KEP allows you to do that. Now this, of course, can be controlled by the driver that is behind that device to have whatever health feature it wants to show for that particular kind of device. So this KEP handles that. The next is KEP 5004, which is extended resource mapping. So you have the legacy device plugin API and you have the new DRA. You kind of want to give folks a good transition between those. So this KEP does that. So you can kind of use the older expression format that was for device plugin API, but under the hood that would be converted to DRA so that you can smoothly transition to the new DRA paradigm instead of using the old device plugin API. The next one is KEP 5075, which is DRA consumable capacity. So in structured parameters, the KEP that Agustina talked about, in that you have to kind of pre-partition the device that is being served to multiple pods or containers. DRA consumable capacity allows you to do that dynamically. So you can kind of dynamically provision or share a device between any two resource consuming containers. The next one is device binding conditions. Now, a lot of use cases with devices is that this device needs to be ready first. So let's say there is an allocation request for this device. This device will be programmed now to cater to that particular workload. A good example of that is FPGAs. So they need to be programmed according to the place they are getting bound to or the pod that they're getting bound to. So you want to make sure that initialization has been kind of done, and then only you bound that particular device to the pod. So binding conditions kind of enable you to do that. So a lot of DRA goodness coming up in this release. Of course, these features would only go stable or to beta or to the next stages. So a lot of good DRA features and a good space to watch out.
Perfect. And we've gone through a lot of important things that are new in different stages, alpha, beta, GA, but the release is also made of deprecations and removals. And Vyom, you can continue and briefly explain a bit about what they mean and what we have in the 1.34.
Right. So Kubernetes cannot just yank out anything overnight and you wake up tomorrow with a new version, you upgrade your cluster and you say, hey, this thing is gone. So we actually give deprecation warnings to users, active deprecation warning. Whenever you're trying to use that API, you would many times see kubectl saying, hey, this thing is deprecated. You shouldn't be using this. Please switch over. Now, there are a lot of different policies around different kind of features getting deprecated, APIs getting deprecated, something on the user side getting deprecated. So it's a very long policy. You can actually just Google deprecation policy for Kubernetes to kind of go through it all. But what it sums is basically have rules for the entire ecosystem. So you cannot remove a GA deprecated API from Kubernetes. It would be deprecated, but there are currently no plans to remove GA APIs because they were meant for general availability. Even though sometimes we kind of discover this after, hey, this is not the best way to do these things. Let's kind of deprecate this and build a newer thing. Now there are similar policies there for beta and alpha features. How many months would they have to be at least deprecated for before they are removed from release? So there's a whole set of policies that govern deprecations and removals.
And one of those removals, I'll start in my dual role as host and also as Kubernetes, the last emeritus advisor for this release. I can also cover some of the content here. And this is one of the deprecations that follows the process that Vyom just explained. And rightly so, because the manual C group driver configuration option, which is now deprecated, has been a source of problems. The issue essentially, and this this deprecation follows the implementation of the automatic detection mechanism that we now have. But the situation that led to this was the following. Before, we had automatic detection from the runtime of the specific C group driver that the kubelet had defined. We had a sort of split brain situation in which you could configure the kubelet to use a specific C group driver, but then the runtime also configured to use something else. And this led to actually very difficult to troubleshoot situations, because it was very difficult to identify exactly that this was the source of problems. So essentially what happened was that the source of C group driver configuration is now made in the runtime, and the kubelet can automatically detect the correct driver by querying the container runtime. Why this is important? In those circumstances that current Kubernetes users still have the C group driver configuration in the kubelet, they should remove it, because it's something that is now well tested and is now derived from the configuration of the runtime.
Yeah, so this is related to what Fred was just talking about. So yeah, so the deprecation of the manual C group driver config. So Kubernetes is planning to end support for containerd 1.x starting in the 136 release. And that's because containerd 1.x does not implement the new runtime config API that allows for the automatic C group driver detection. Because of that, along with containerd 1.7 being end of life soon, it just made sense for Kubernetes to stop supporting the 1.x versions of containerd. So if you want to continue using containerd, it's recommended that you upgrade to 2.x version soon.
Yeah, and this is the last deprecation. So, and it is about the spec traffic distribution field in a Kubernetes service that allows users to set a preference for how traffic should be routed to service endpoints. So KEP 3015 deprecates prefer close and introduces two additional values. The first one is prefer same zone, which is equivalent to the deprecated prefer closed. It's just an alias for prefer closed. And the second one is prefer same node, which prioritizes sending traffic to endpoints on the same node as the client. This feature was introduced in Kubernetes 1.33 as alpha. It has now graduated to beta in Kubernetes 1.34, and it is enabled by default. So again, prefer close is deprecated, so use prefer same zone for the same behavior before it goes away. One thing to note is that the removal of prefer close is not part of KEP 3015, but still it will be removed eventually.
Thank you very much. And we are quickly coming to the final part of this live webinar with a final look into the release team. Vyom?
Yes, so I am assuming a lot of you might be wondering, what does this team of 35 people do? What's this release team about? Well, first of all, we are responsible for organizing webinars like this to begin with. There's a lot that goes behind the scenes for getting a Kubernetes release out of the gate. It's not just the code that is there that a lot of end users see. It's a huge process around that. So Kubernetes needs to be tested, and someone kind of needs to monitor that CI to see what's happening. And flakes are notoriously difficult to observe because sometimes they just can be due to network failures that happen at the infra side, nothing related to the code of Kubernetes. There's a lot of documentation and there's a lot of gathering to get people to follow guidelines, to get people to follow rules and respect timelines so that Kubernetes can be shipped in a timely manner. And sometimes there are groundbreaking deprecations like removal of Docker shim, which the release team needs to kind of convey properly to folks so that they don't misinterpret what's actually being deprecated and there isn't any chaos that is in the community, or nobody's going nuts on Twitter or Blue Sky saying, oh my God, they have deprecated this. So release team is responsible for a lot of this, for coordinating the entire release effort and making sure that the release gets out on time. And we kind of publish a schedule beforehand so that every release cut or everything's happen at the time it's supposed to be. And some of the release team updates, the first and foremost is that v1.34 was the last cycle with an emeritus advisor, who is Fred, for this release. And this role is now being removed, and it would be replaced by release team sub-project lead. Now, this is not a bad thing for the Kubernetes release team in general, because if anything, the release team is getting more stable because the sub-project lead stays on for a longer period of time. So Kat's the sub-project lead right now, and she would be guiding the release team through multiple releases. So if there is a single sub-project lead, then they kind of can see how the release team is evolving over cycles so that they can improve things. So this is the last cycle of having an emeritus advisor, and I was very glad to have you, Fred, as my emeritus advisor. And now the stage is yours.
Yeah, thank you very much. Some quick words. This is obviously a huge honor for me, and it was a great release to be an emeritus advisor. Essential because everyone did their work so well that I had a very easy life, which goes directly into what you just said. I've been a member of the Kubernetes release team since 1.25, and I've been a member of all except one release since then. I've been in different roles, including release lead for 1.32. And the one thing that it's obvious is that the maturity of the process that we have now has improved consistently in all releases that I've been participating in, which makes the emeritus advisor role as a source of a sort of informal gathering of knowledge to be passed and to help in dubious situations. This has lost its relevance precisely because of the work of the release, SIG release sub-project that has turned that more diffuse knowledge into something well documented and clear for everyone. That being said, I mean, 125 to 134, it has been a good run, and it's a huge honor for me to be the one that closes the door on the emeritus advisor role.
Well, thank you, Fred. Thank you for everything that you have done for this team.
Thank you so much, Fred. I'll cover the last two release team updates. We have published 18 feature blogs as part of Kubernetes 134. So these are the post-release blogs that come out every weekday after the release announcement. All of them are now available at kubernetes.io/blog. So we want to thank all feature blog authors. We continue to beat the record on the amount of post-release blogs, which will likely require us to be more picky in the future, but it is a nice problem to have. And lastly, during the 134 release cycle, we had contributions from over 100 different companies and almost 500 individuals. So shout out to everyone out there who made this release possible. For the last one, we have a recap. Release notes are available, as always, in the Kubernetes repository. The release announcement is published also in kubernetes.io/blog. Head over there if you would like more 134 highlights. This webinar was just a selection of the over 40 highlights covered in the blog. And finally, this deck will be available in GitHub.
Amazing. And if you'd like to kind of ask for help at this stage, so get involved. You know, the Kubernetes release team is such a platform for new contributors who are not familiar with this enormous ecosystem. It can be very daunting for people to kind of see Kubernetes as a project or even go through the source code. So it can be very daunting if you are not tuned to the practices that Kubernetes follows. And Kubernetes release team is a great place to start contributing to Kubernetes. Now, of course, there are a lot of other special interest groups, so just find whatever aligns with you. But since I was the release lead, I would kind of preach you for joining the release team and applying for the Kubernetes release team in the next cycle. The applications for v1.35 are closed now, and v1.35 is actually a work in progress. So for the next release cycle, you can join the SIG release channel on the Kubernetes Slack, or just follow the Kubernetes mailing list. Whenever the applications are open for joining the Kubernetes release team, you would get a notification over there and apply. It does not matter how much experience you have. The Kubernetes release team absolutely picks contributors with no prior experience in Kubernetes. Actually, I was one. I actually had no upstream contribution experience to Kubernetes. I contributed to other CNC projects, but not Kubernetes directly. And you can see my journey. I'm the release lead now. So the program is completely open to beginners, or you have to have zero contributions to open source in general. So apply and get involved.
Indeed. And I guess that's the way that all of us ended up here, simply through joining the community and doing something that we like, and by doing so, helping others. We've finally reached the end of our live session, not before taking some of the questions. Let me quickly go into them into the chat. We have a couple of questions. I've also shared some of the answers as links in the chat, but maybe we can quickly go through them. The first one is around KYAML. One of them was actually just before Vyom presented the highlights, the other one around the same time. I mean, I maybe Vyom, you want to expand on it. For me, I would say that the main purpose of KYAML is to remove ambiguity that exists in the existing YAML spec, which is ambiguity isn't that much of a concern when you're doing human readable things, but for a more programmatic approach, the fact that you can have things that depend on different levels of quoting or different indentation and stuff like that quickly breaks in unexpected ways. I would say that KYAML is YAML reduced to a subset that is absolutely unambiguous and doesn't leave anything to be guessed.
Yeah, I think that covers all of it. I just want to touch on the last point that says also it's integrated with Helm charts as well. So KYAML is integrated with anything that accepts YAML. So Helm, Kyverno, or whatever you have. So KYAML is purely a dialect of YAML. It's the same thing, but it's dressed differently, so that looks pretty and is more functional. So it's acceptable by all YAML parsers in any ecosystem.
Excellent. And we actually also have in the sneak peek and on the actual release blog that Agustina was just mentioning, we have some additional explanation which covers the Helm integration as well. We have a final question here, which is around the swap introduction, the node swap feature. I've linked to the actual cap in the answers, because the question is obviously very pertinent. Doesn't it make things more unstable? The cap actually identifies the motivation behind it, which is to provide the ability to use a part of the swap that can have a positive impact in some of the workloads, and also has a section on best practices that are meant exactly to address any instability concerns by making sure that the critical components are prioritized and that the addition of this possibility doesn't negatively impact the health and performance of the Kubernetes cluster.
We can also add something that was said by Jenny during the presentation. That is that swap is disabled by default. So if you don't want to use it, it's not on by default. You have to turn it on if you want to use it.
Excellent. And I think that we've reached the ends of our session. Thank you, everyone, for being here. It's been, as I mentioned, a double pleasure on my part, both as a CNCF ambassador and host of this live session, and also as the last emeritus advisor of the Kubernetes release. I've been honored to share this release with Viom, Jenny, and Agustina, and many others. Thank you, everyone, for joining and for your questions. We thoroughly enjoyed this interaction, and do go into the CNCF calendar to check for the next events that we have. And thank you for joining us today, and we hope to see you again soon. Thank you, everyone, and I will now end the session. And any goodbyes, now is the time.
Bye, everyone. Thank you for joining.
Bye-bye.
Thank you all. Cheers. Bye-bye.